the Pythagorean theorem and how we can turn the equation of a line or the graph of a line into a Pythagorean theorem problem instead of using a distance formula. It's sometimes a little bit quicker. So the way we would do that, we said, is we would draw a vertical line and a horizontal line, which would make a right angle. Then we could count spaces, 1, 2, 3 spaces, 1, 2, 3, 4 spaces. And as we learned in the Pythagorean theorem, with a right angle, the two sides we call A and B, the hypotenuse C. The hypotenuse is across from the 90, so that would be the red line we're looking for. And what we learned is A squared plus B squared equals C squared. So that would mean 3 squared plus 4 squared equals 5 squared. Or if we don't get ahead of ourselves, equals x squared. 9 plus 16 is x squared. And then x squared is 25. So the last step we usually do in our square root is our square root in a Pythagorean theorem problem. We square root both sides to get from x squared to just x. Okay, and part of the reason for this, we don't need to know, but we're talking about real squares, we said. So what we're saying is a 3 by 3, a 3 squared, which would be here, plus a 4 by 4, or a 4 squared, will always fit this pattern that Pythagoras had learned. And the pattern was that 4 by 4 square has 16, a 3 by 3 square has 9. When you add them together, you'll always have that number in the hypotenuse spot. You'll have a square with 25, a 9 plus 16. And a square with 25 has the sides of 5 and 5. So the root or square's root of its one side would be 5, which is what we got. So we don't need to even know about the squares to use the Pythagorean theorem. But luckily for us, our graph is made out of squares, right? So everything lines up perfectly here. I can actually make a 3 by 3 square and make a 4 by 4 square. And so this process of realizing a pattern with little squares or stones most likely were used can then be applied generally and made into a formula, a distance formula, so that we could find how long that line is even if we don't have a graph. And we could find how long that line is no matter what numbers we're using. So let's take a look at why or how we get the distance formula from the Pythagorean theorem. So looking at the same red line, I'm going to do something my teacher always would encourage. And she would always recommend we take the time to fill out our graph properly. And we always tend to do this, but we forget what sometimes we're really trying to represent or signify. We're trying to remind ourselves that the x controls the left or right. The y controls the vertical line or up and down. That's going to be important. So if we wanted to find how long each side was, what we did before was we counted. So something we could also do is we can use what we used to call the ruler method. Because when you use a ruler and you don't start at 0, how do you get the distance between two numbers? So if you start at 31 and measure something, and you go to 51, how much is in between? And the distance in between we can get by subtracting. 51 take away 31 is 20. So what we can do to get the distance between two numbers is subtract. We can subtract the other way in the opposite direction. 31 take away 51 is negative 20. So we still know that the space in between is 20. We can use the absolute value to turn it into positive. Because in real life we don't have negative lengths. You don't have a negative 10-foot tall tree. So if we couldn't count spaces, let's say we didn't have graphing lines, and it was maybe harder to graph, or we graphed unevenly. Sometimes when we leave our little notches, the graph's uneven. Then counting could kind of cause you to make mistakes. So what we could do is we could use the ruler method. So we'll just do that with the bottom line. Bottom line starts at 2, goes to 3, 4, 5, 6, goes to 6. So how could we find how long that line was? 6 take away 2 would give us 4, which is what we had found. So if we can subtract the two numbers, we can find that side. So here we have 2, 3, 4, and 5. So if we want to find the vertical line, we started at 5 when we went down to 2. We're looking at the y-axis because we're looking at a vertical line. So 5 take away 2 gives us 3. And if you remember when we counted, those were the two numbers, 3 and 4. So we're finding now that if we subtract the two numbers on the line, on the number line, or on the graph, you can find how far apart the line is, or how far apart the two numbers are. So then we're going to use that, because not only what if there's no grid, what if there are no numbers? So that's what a formula is. A formula works when there are no numbers, and it allows you to input or enter something and get an answer, no matter which numbers you're using. So if we use 10,343 and 12,770, just random numbers, and then that was one point, and then 7530 is another point, we can plug it into our formula. So how would we do that? It's actually quite simple. We want to know where this point here is, point A, let's say. And to find point A, to point B, here's point B, we're using the spot on the x-axis from here to here. So let's highlight it in yellow. We're looking at a horizontal line AB. It's the same distance as this spot to this spot on the graph. So if we don't have a number for that and we want to just say any number, we could say, well, this is the first x spot, and this would be the second x spot, where B ends. So A begins at x1 and B begins at x2. Okay, then we want to refresh our memory that that's what the x-axis does, right? Remember, the x controls left and right. The y-axis controls vertical lines. So if we're going to look at the y-axis and we can see the y-axis is a vertical line, then we're going to remember that the y value controls vertical lines. So if we want to know how far apart it is from C to B, we know C ends right around there and B starts or ends right around there on the y-axis for the vertical line. So we can say this is the first y spot, this is the second y spot. So really, I mean, we could just make it simple and say, to find how far apart the yellow line is, we can subtract x2 minus x1. And you might recognize that from our distance formula. The vertical line is going to be y2 minus y1. Now we can make it a little bit more complicated by finding each point. So A would be at the point x1, y1. To the right, this first space is x1, and up the first space is y1. B is to the right x2, and then up the amount where y1 is. And then point C is to the right x2 also, and it goes up to the second y spot. So just to point out, right, what we're doing is we're looking at a vertical line, so we're looking at the y2 minus y1, because y2 minus y1 will give us our vertical value. Then when we look at the horizontal line, right, we're looking at the x values. So we would look at x1 and x2 here and subtract them. So it becomes x2 minus x1. So remember, in our Pythagorean theorem, we took each side and we said a squared plus b squared equals c squared. So we're going to take the same thing, right? One of these sides would be the blue. One of these sides would be the x2 minus x1. Those would be kind of like our a and b. So what we kind of have here is y2 minus y1 as one side, x2 minus x1 as the other side. So if I use the Pythagorean theorem, I'm going to get x2 minus x1, or this side right here, and I'm going to square it. Plus, I'm going to take y2, take away y1, and square it. So I'm doing the Pythagorean theorem. But instead of using a and b, I'm using what we found for the blue and yellow lines, y2 minus y1 and x2 minus x1. And the Pythagorean theorem says a squared plus b squared equals c squared. So I need to put the squared here. And when we want to go from c squared to just c, remember what we did at the very end is we square root both sides. And what we end up with here is a formula for distance, that we can input or enter any number values for 2 points. And there'll be a point with a x1, y1 and a point with a x2, y2. And when we plug it in, we'll get the distance of that line. So we're using the same steps or same process as the Pythagorean theorem, only we're replacing x2 minus x1 for the x value because we don't know it. And then we're also replacing y2 minus y1 because we don't have numbers for it, and we're putting that in for a spot for the Pythagorean theorem. And by doing that, we now have a formula where we can enter any number values and find the distance of a line. So it all comes from learning and understanding those square properties in the Pythagorean theorem.